Okay, today's video is on lesson 6.1, solving one-step linear inequalities. So before we get into linear inequalities, let's look at these first two problems that are just equations. So this should look pretty familiar to you. We have x divided by 4 equals 12. And so when it's an equation, we just multiply both sides by 4 as I did here. And so then those cancel out the 4's and we end up with x equals 48. So if I were to ask you to graph that, which is not something we typically do, but if you were to graph it, you would just put a dot at the number 48 on the number line. So this should be a review. Same with this problem here. We have 8x equals negative 32. This time, because it's multiplication with the problem, we're going to divide both sides by 8 to eliminate the 8 with the x. And we're going to get x is equal to negative 4. Again, if I were to ask you to graph that, you would put a dot at negative 4 on the number line. Okay, so that's just a quick review of how to solve equations. And to solve inequalities, if you look down here at this problem, we don't do anything different. So I took this first equation that I wrote up here, and I'm just solving it, but instead I changed the inequality, or the equation equal sign to an inequality sign. So I still go through the same process of multiplying both sides by 4, and I get x is greater than or equal to 48. So I kept my inequality sign consistent throughout. So if you will, the alligator mouth is always open to the x in all three of those steps. So now if I were to solve this, the answer is x is greater than or equal to 48. So 48 is a possibility, so I color that in, but we're also looking for the numbers that are bigger than 48. So I'm going to shade these numbers in to the right. And I make sure that I include shading in the arrow because that indicates that all the numbers that continue on that are not written here are also solutions. So because 48, this says it's equal to or greater than, since 48 is a possibility, I colored in and then I shade everything that's bigger than 48. This next example, again, I took this equation up here and I just put an inequality sign in between. So 8x is less than or equal to negative 32. Divide both sides by 8. X is going to be less than or equal to negative 4. So again, it's less than or equal to, so negative 4 is part of my solution. So I put a closed dot there, and this time I'm going to shade the numbers that are less than negative 4, which are negative 5, negative 6, etc. Again, making sure I shade the arrow here. Now, just be really careful because a very common mistake is that people will number their number lines incorrectly. So just make sure that when, especially you're numbering your negatives on the number line, that you include, you put them in order from least to greatest. Don't switch the order of those. All right, let's look at another example. This time, 6x is greater than negative 6. So we're going to divide both sides by 6, and we're going to get x is greater than negative 1. Now in this problem, x is greater than negative 1. That does not include negative 1. So I'm going to put an open circle at negative 1, and I'm not going to color it in because it's not equal to negative 1. It has to be bigger than negative 1. So like negative 0.99999 is a solution, and that indicates by this open circle that that's part of the solution. And so I'm looking for everything that's bigger than negative 1, so again I shade to the right. Here's another problem, x plus 7. So far we've looked at multiplication and division. We can do the same thing with addition and subtraction. Take 7 away from both sides, so x is less than 11. So again, an open circle, because it's not equal to, it's just less than. So an open circle at 11, and everything's shaded to the left. All right, here's an example, and I have this one starred because it's a little bit different. So here we have 3 minus x is greater than 6. So I'm going to take 3 away from both sides, and I get negative x is greater than 3. However, I don't want negative x. I want it to always be positive, just like when we solved equations. So I'm going to divide everything by negative 3. So when I do that, this changes to x is less than negative 3. So this inequality sign has to flip because the sign of this number changed to the opposite. So then, and I did this graph incorrectly here, this should be negative 3, negative 4, negative 5. It should still be shaded the same way, but because I forgot my negative sign up here, my number line is incorrect. So we need to fix that. So make sure you fix that. There should be negative 3, negative 4, negative 5, negative 6 and still shade that direction. So let's look at what that would look like as far as a solution then and why we have to switch it. So let's put negative 4, negative 5, negative 6. So negative 6 is a possibility. So if I were to go back over here to my equation and I write 3 minus negative 6 has to be greater than 6. And so by double sweeping, I get 9 is greater than 6. So that is, in fact, an answer. Now, again, if I switch these here, 0 is not a solution. So if I put in 0 here, it shouldn't work out. And 3 minus 0 is not greater than 6, because 3 minus 0 is 3, and 3 is not greater than 6. So that's one of the reasons why we have to flip. When we have a negative variable and we change it to a positive, we have to switch that inequality sign. You'll see another example of that here in this next problem. Again, I have these two problems starred because we have negative 3x is less than or equal to 9. So this coefficient with the x is negative, so I'm going to divide both sides by negative 3. Because the 9 goes from a positive to a negative when I divide here, I have to flip my inequality sign right here. So x has to be greater than or equal to negative 3. And then I plot that just as I did before. Here's another one. This time I'm dividing by a negative 7, so I'm going to multiply both sides by negative 7. X is going to be greater than or equal to 21, but because this number that's positive 3 here changes to a negative when I multiply it by negative 7, I switch the inequality sign. So really the answer is x is less than or equal to negative 21. So that indicates there on that number line. Okay, a couple important things that we need to note. So please make sure you have these written down. If the inequality sign does not include an equal sign, so it's just greater than or less than, on our graph it's an open circle. If we have the inequality sign with it, so if it's greater than or equal to, less than or equal to, that's when we have a closed dot. Then when you multiply or divide by a negative number on each side of the inequality sign flips, and that's like these last couple examples that we looked at up here. So the inequality sign has to flip when it goes from a positive to a negative or a negative to a positive. So here are a couple problems I'd like you to try for homework tonight. There are 5 of them total. So I would like you to go ahead and pause the video, make sure you write these down. I want you to not only solve them, but I want you to graph them as well on a number line. So you're going to have to draw your own number line. All right, get those 5 problems done for class tomorrow. Have a good night. See you tomorrow.